Sometimes we're faced with integration problems that can't be used with, let's say, U substitution or some of our more straightforward techniques. So we might need to use something called integration by parts. Now, at first glance, these functions seem to be products of two functions, and they are x times e to the x times ln of x squared times e to the 3x, x times the square root of x plus 1. And if we were finding a derivative, we would use a product rule. Well, we don't have a straight-up product rule for antiderivatives here, but we can use something called integration by parts, which is actually derived from the product rule for derivatives. We won't go through the derivation here. You can find that in your textbook. But we're going to move on to, we're going to do our first example, talk a little bit more about the formula and some tips for using this formula. So again, the integration by parts is if we have the integral of a product of two functions where one is the derivative of a function and the other one is just a function. And don't worry about that too much right now. Just notice this formula here. The integral of u dv is equal to uv minus the integral of v du. So in other words, we're going to use this formula to find a solution to a problem, an integral, or evaluate an integral like x e to the x dx. So notice it's set up as the integral of u dv. So it's the integral of some function u and then some function that's a derivative of a function. So we want to figure out, okay, what is u in our problem and what is dv in our problem? So the tips here are to choose u so that u prime is simpler than u, and let dv be the slightly more complicated factor, but one that you know how to integrate. So in this example, what I might choose for u, something that its derivative is simpler, well, that would be x. I'm going to choose that to be my u, because notice what is the derivative of x? The derivative of x is 1. So the derivative is simpler than the function we started out with. And what do we want to choose for dv? Well, what we're going to choose for dv is what's left over. So this is going to be our dv. Okay. Now, on the next slide, we'll talk about what we're going to do with that. So let's recall, we said we're going to let u equal x. And we're going to let dv equal e to the x dx. And let's write down our formula again. So this is u dv is equal to uv minus the integral of v du. Okay. So we've identified u and dv, we've identified what dv is, and then we just need to find what v is and what du is, right? Because those are the other parts of the problem that I don't have. All right, so we need to find, we said du, and we need to find v, because we're going to use it both here and here. All right, so we have u, we need to find du, we need to find the differential. So in other words, taking the derivative on both sides, the derivative of u is du, the differential of u is du, and the differential of x is 1 dx, or just dx. If that makes you a little uncomfortable, you can think of it as the derivative of u with respect to x is 1, and then multiply both sides by by dx, and the dx is on the left-hand side will cancel, and we're left with du equals dx. So in any case, that's what we end up with, du equals dx. Then on the other side here, we have dv, and we want v. Well, how do we find v? Well, we integrate both sides. So we went from u to du, we differentiated both sides. To go from dv to v, we integrate both sides. And the antiderivative of dv, or 1 dv, is just going to be v. And the antiderivative of e to the x is e to the x. So now I have all the parts that I need. Okay. So the integral of x e to the x dx is equal to u times v. Where's u? Times v. So that's x times e to the x minus v, again, the integral of v, e to the x, and du is dx. Well, now we've gone from the integral of x e to the x to now the integral of just e to the x. So I finish this off by rewriting x e to the x minus the integral of e to the x, which is e to the x, and then of course always plus our constant of integration. You should check that the derivative of x e to the x minus e to the x plus c is the function we started with. Okay, I'll leave you to do that to make sure that that is the correct answer. Something we should always do when we integrate is take the derivative, make sure we got back what we started with. Okay, we're going to try one more example in this video, and then I'll have some other examples in another video to follow. So for right example, change it up a little bit, 3x e to the 2x. So again, I'm going to remind us of what our formula is. U dv is equal to uv minus the integral of v du. So again, we want to pick u and we want to pick dv. Pick your u so that its derivative is something simpler. And usually you want to pick something like 3x or x or anything like that. So I'm going to choose u to be 3x, and then its derivative, its differential, is going to be 3 dx. And again, then what's left over is going to be my dv. Okay, so it's the derivative of some function, so I want the original. So I want to integrate both sides. So in integrating both sides, the left-hand side, the integral of dv is just v, and v then is the integral of e to the 2x, which is going to be e to the 2x times 1/2. So that's v. So we have all the parts we need. Right? We have u, and we have du, and we have v that we need for the parts here. Oops. Don't want to point out that u. I want to point out this u. Okay. So I go ahead and plug back in. U times v. U times v. So that's 3 times 1/2 is 3/2, and an x, and an e to the 2x. Minus the integral of v, again, 1/2, e to the 2x. Now I need du this time. So times 3 dx. Okay, so this is 3/2 x e to the 2x minus, now I've got a 3 times a 1/2, so I'll bring that out to the front, and then integrate e to the 2x. So this is 3/2 x e to the 2x minus 3/2 times the integral of e to the 2x, which we've already integrated once before, so I have that handy. That's 1/2 e to the 2x, of course, plus our constant of integration. So this is going to be 3/2 x e to the 2x minus 3/2 times 1/2 is 3/4 e to the 2x plus c. So that's it for now. So again, the tips are you choose your u to be something that when you take its derivative, you get something simpler, and then the rest is going to be your dv. It's going to be something that you do know how to find the antiderivative of, and then it's just a matter of using the formula.